Welcome to the section 4.6 notes. Go ahead, pause the video and see if you can do these warm-up problems. Remember, when you're finding the inverse, you exchange your x and your y, and then you solve for y again. So pause the video, see if you can find the inverse to these, unpause, and see how you did. So for this first one, to find the inverse, I'm going to start with x equals y plus 3. Now I need to solve for y, so subtract 3 from both sides. Inverse that first one is going to be y equals x minus 3. Okay, the second one, I'm going to start by finding the first equation, so what that relationship would be. So I can see that I'm going up by 1's and x's, up by 2's and y's, so that means my slope is 2. And my b value, if I'd gone back one more, would be -3. So when I exchange the x and the y, now I add 3 to both sides and divide by 2. To get y is equal to half x plus 3/2. So today we're going to be talking about the graphs of inverse trig functions, and more so just kind of what trig functions are and how to use them. So for this first example, on the top left here we've got our normal graph of y equals sine x. Here is what we have for the function of y equals sine inverse of x, or sometimes it's called arc sine of x. These two things are the exact same. Sine inverse or arc sine are the exact same thing. That picture has these restrictions. The reason it has those restrictions is, if we remember, when we exchange our x and our y's, we're basically just rotating our graph a little bit. So what we would have actually had is we would have had a function that looks more like this. All right. If you remember your vertical line test, this is not going to be a function. It doesn't pass because it fails the vertical line test immediately. So where these restrictions comes from is these are the values of x in our normal graph that give us our minimum and our maximum values of 1. Okay, so we went 1 to the left and 1 to the right. So our y values go from -pi/2 to +pi/2. Okay, that's where those things come from. There's not some random arbitrary thing. Okay, if you plug in -pi/2 and x here, you're going to get -1. If you plug in pi/2 here, you're going to get +1. If I replace the x and the y's, okay, I still have those same numbers. Cosine, pretty much the exact same idea. Cosine inverse of x, or arc cosine of x, our restrictions for this one is between 0 and pi for y, because again, if I was to graph this as if I was to actually graph the entire thing after exchanging the x and the y, I'm going to have, oops, put that one in the wrong spot. I'm going to have something more like that, which again immediately fails that vertical line test. So we go from 0 to pi because cosine of 0 is going to equal 1, cosine of pi is going to equal -1. Okay, but now I'm replacing my x and my y value, so my x is -1. That gives me a 0. If I plug in x is +1, then I'm going to get a 0. I said -1 gives me a 0. That one should have given me pi. I misspoke. Okay. And then tangent, we've got tangent inverse and arc tangent of x. We've got the restrictions from -pi/2 to pi/2 again, because that's one period in the normal function. We just get rid of all of the things to the left and right because now they'd be above and below. So we're focusing on these restrictions so that we can treat this thing as a function. Okay, remember, if you can have 2 outputs for 1 input, you don't have a function. We're trying to limit ourselves so that each input has exactly 1 output. So where these are going to be helpful is answering these types of questions. For this question, normally we can just think, okay, sine of what number gives me 1/2? Well, I know sine is positive in the top and the bottom. So I know I would have had these triangles, and I would have found that x is equal to pi/6, or that would have been this first one, or if I had kept going, it would have been 5 pi over 6. But it says from negative 2 pi to positive 2 pi, so I've got to continue. Okay, I want to have no more positive ones, so now I'll just go negative. So from the x-axis going clockwise to get to 5 pi over 6, that would have been negative 7 pi over 6, or if I'd gone all the way around, negative 11 pi over 6. Those are my values of x. That would give me sine of x equaling 1/2. If I want cosine of x to equal negative square root of 2 over 2, I know that's our pi over 4 angle, or 45-degree angle, but cosine is going to be negative in quadrant 2 and in quadrant 3. Okay, so going that way, as I said, we already know it's pi over 4 is our reference angle. So pi over 4 in that second quadrant is going to be 3 pi over 4. In the third quadrant, it's going to be 5 pi over 4. Those are all the positive ones that are going to work. Now I've got to go negative. So if I go negative, it's actually just going to be negative 3 pi over 4 and negative 5 pi over 4. It's not negative just because of these numbers. We just write a negative in front. It's just based off of the angle that actually came up. Because if I go 3 pi over 4 and 3 pi over 4 this way, I get to that same angle using the same reference angle. 45 degrees or pi over 4 radians kind of gives us special circumstances. So now we are actually going to use our inverse trig functions instead of just, oh, what values of x would make this thing true. So for this first one, I want to evaluate arctangent or tangent inverse of negative pi over 3. So if I'm thinking of tangent, where do I get pi over, or I said pi over 3, square root of 3, excuse me. So tangent, I know if I think of CAST or all students take classes, one of those, I should know that tangent is going to be negative in this quadrant and in that quadrant. Okay, so I know that negative square root of 3 means I can't have that 45-degree angle because obviously that would have been 1. I know sine over cosine is what I have for tangent. So I want to have the one with the square root of 3 on top. So I'm going to have that situation. So sine of x is going to be square root of 3 over 2 when it's very, very tall. So I have this one right there and that one right there. Those are my angles. All right, so I need to think of my restrictions. So what I'm going to actually do is ignore the restrictions, figure out what these values could be, and then eliminate using the restrictions. So this is going to equal, if I had gone this way, the angle measurement, okay, this is a reference angle of pi over 3. This is 2 pi over 3. Okay, that would have given me this first one, or I could have come all the way around. That would be 3 pi over 3, 4 pi over 3, 5 pi over 3. Okay, those are my positive values. I'm going to do the same thing and find my negative values. My negative values here are going to be negative pi over 3, and then, well, negative pi over 3, negative 2 pi, negative 3 pi, negative 4 pi over 3. But now I need to think back to my restrictions. So if I just kind of scroll back here, my restrictions are between negative pi over 2 and positive pi over 2. So between pi over 2 and negative pi over 2, I got to think to myself, well, this one is bigger than pi over 2, so that one doesn't work. This one is smaller than negative pi over 2, so that one doesn't work. So I've got to think of these next two. 2 pi over 3 is also bigger than pi over 2, so my answer is negative pi over 3. For sine inverse of negative 1/2, okay, that tells me I'm going to have the bottom 2 quadrants possible. So I'm going to have there and there. That was a terrible triangle. Wasn't much better, but I'm going to go with it. So I would know that my values, if I'm thinking of sine equaling 1/2, I know that that's got to be a pi over 6. But to get all the way around to here, that's going to be 7 pi over 6. Or 11 pi over 6. Again, I'm also going to find the negatives, which is negative pi over 6 and negative 5 pi over 6. Okay, I got those just by saying what's 2 pi minus pi over 6, what's pi minus pi over 6, and then realize that's supposed to be a negative. So again, I got to think of my restrictions. So if I scroll back up to sine, my restrictions were again negative pi over 2 to positive pi over 2. So from negative pi over 2 to positive pi over 2, that one's too big, that one's too big, that one's too small technically. We're going to have negative pi over 6 as our answer. And this last one, there's a few pieces that are happening, so right away I'm going to ignore the sine piece. Just worry about that cosine inverse, or that arc sine. So cosine is going to be negative 1/2 on one of these left two quadrants, and it's got to be one of those tall ones. So if I just had cosine inverse of negative 1/2, this would equal, okay, this is going to be another pi over 3 angle. So pi over 3 is our reference angle, so this could be 2 pi over 3, okay, just like that first triangle we just used. Or I could have had 3 pi over 3 would have been right here. 4 pi over 3 would work for positive. Going negative would have been negative 2 pi over 3 and negative 4 pi over 3. My cosine inverse, again, I'll just scroll back up so we can see, goes from 0 to pi. That one's different than the other one. So from 0 to pi, I can immediately throw out these negatives. And then 4 pi over 3 is bigger than pi, so it would be 2 pi over 3. But now I have to worry about that sine value, because what I actually now have is sine of 2 pi over 3. So sine of 2 pi over 3 is still just that triangle. Okay, sine of 2 pi over 3 is going to be square root of 3 over 2. Okay, so my answer to sine of cosine inverse of negative 1/2 is equal to square root of 3 over 2. It's a positive because sine is positive in that quadrant. So for these ones, you're using a calculator to evaluate the following. We've done these before, so hopefully you're able to do them. You just hit second sine to get the sine inverse on your calculator, and then put those numbers in. Okay, it says round to the nearest tenth of a degree. These should be your answers. If they are not, double check that you are in degree mode. Anytime it says round to a nearest degree, make sure you're in degree mode. If it says something about radians, make sure you are in radians mode. And then there is your homework assignment. Hope everybody has a great day.